Hello everyone and welcome back to our course. In this lecture, we're going to start our project of feature analysis and data science with stocks. First, we're going to load in our data set. So join me at Google Colab by visiting colab.research.google.com. This is an online code editor that we can use to code in Python. And we're going to get started. First, we're going to install and import Yahoo Finance. So call pip install yfinance, then run this code cell. The exclamation mark means that we are in the console and we are collecting and downloading yfinance, Yahoo Finance. Great, okay, once you get this message successfully installed, we can now use Yahoo Finance. We do have to import it, yfinance like this, and then we'll be able to use its functions. For example, I'm going to use yfinance.download. So this is going to allow me to download some data. Inside of this download function, first we're going to pass in a tickers argument. This can be one or more stock tickers or stock symbols that you want to use. So I'm going to pass in here my stock symbol variable, which I'm going to create. We can choose any stock, for example, Tesla, which has the ticker or symbol TSLA. Make sure it's capitalized. Then we have a start argument. This is going to represent our start date, which is when we want to begin the data set. And in my case, I'm going to define start date. Let's start at 2016-01-01. All right. Then we're going to pass in another argument known as end. This is going to be the end date for our data set. End date, and we'll create another variable called end date. Just make sure that the end date has actually passed so far. It can't be in the future because we can't fetch data that hasn't existed yet. So I'm going to do 2021-01-01. This will give me a neat 5 years worth of data. Okay, great. The result of this is going to be a data set. And I can print out that variable and view what it contains. Okay, and look here. We can see we have 6 different columns. The date is our index column, so it doesn't count. It's just used to index each row. Beginning at 2016-01-04, because we only have the values for weekdays, and ending at 2020-12-31. So almost 5 years of data. We have open, which is the opening price of the stock on that day. High, which is the high price of the stock on that day. Low, which is the low price of the stock on that day. Close, which is the closing price of the stock on that day. Adjusted close, which is the adjusted closing price of the stock on that day. And the volume, which is the number of trades. Awesome. Okay, and just like that, we've been able to grab our data set. We can also call dataset.info here to get some information about the type. And you can see here the type is a pandas data frame. The pandas data frame type is very commonly used because it allows us to work with our tables much faster and we're exposed to a lot more functions. Okay, coming up now, we can actually create more data, more columns here. So I'm going to create a new code cell. I'm going to grab my data set and I'm going to create a new column. This column is going to be increase or decrease. Then I'm going to use the NumPy library in order to set the values at this column. So I do have to import NumPy in order to use it. I'm going to use NumPy and I'm going to use where to set a condition, and I will fill that column depending on the condition. So I'm going to check where the data set at the volume dot shift of -1 is greater than the data set at the volume. So I'm checking where the data set at the previous row at the column volume was greater than the data set at the current volume. In that case, I'm going to populate that row with 1 at this new column. Otherwise, I'll populate it with 0. So if the previous day is greater than the current day, that means we had a drop. So this would actually be called decrease because 1 would be true, 0 would be false. We could do it the other way as well. We could have a less than here and we could set it to 1 for increase and 0 for decrease. Doesn't matter. The way we have it now is if the previous day is greater than the current day, we'll populate the column with 1 because we had a decrease. Otherwise, we'll populate it with 0. Then I can run this code cell and we'll see we now have a decrease column. We have a 1 if the volume decreased, and we have a 0 if the volume increased. Next, let's add some more columns. For example, we can determine if we should buy or sell the stock depending on if the price increases or decreases. So I'm going to make a new code cell. I'm going to grab the data set and I'm going to make a column buy or sell. Then I'm going to use NumPy again, and I'm going to find where the data set at one of the columns like add close typically is used. I'm going to check the row before it with shift -1. If that is greater than the data set at the present day add close, that means that the price decreased, which means that I should sell. So I can have here a 1 for sell and a -1 or a 0 for do not sell or buy because the price dropped. This is quite a rudimentary way of determining whether to buy or sell. It's a simple strategy, but it will work for this case. All right, so I can just call this, let's see, sell, because if, or buy, rather, because if price dropped, then we have 1 for buy, -1 for do not buy. So I can now paste the data set again, and we will see a new column called buy will have been created. If the price decreased, we have a -1 on that adjusted closing column. We can also do this on any column we want. We could determine whether we want to buy or sell on any of the columns. Doesn't really matter. Typically, adjusted closing price is used. All right, next up, let's add in another column. All right, so what else might we want to add to our data set? Well, we might want to calculate the return. What return are we getting on our investment? So I'm going to make a new code cell here. At data set, I'm going to make a returns column. I'm going to grab the data set and I'm going to use the add close, adjusted closing column, and I'm going to call the %change function. All right, then I am going to paste out that data set variable again just to see what we now have. All right, so now we have this return for the first day. We don't have any returns, but then we can see the returns at each day. Because the first row is not a number, we want to drop this row. To drop a row from the data set, we're going to grab the data set and assign it to equal dataset.drop_NA. That is going to remove any null values or not a number values. As well, one final column that we can create a class column that tells us whether our return was positive or negative. So I'm going to make another code cell at the data set. I'm going to create here our class column. I'm going to use NumPy to set a condition. So where the data set at the returns column of the previous day with shift -1, if that was greater than the data set at the current returns column, then we want the class to be that the return has dropped. So we have a negative return. Otherwise, we have a positive return. Then I can paste the data set again and run the code cell. Now we will see here we have a class column, positive or negative. If returns was positive, then our class is positive. If our returns was negative, our class is negative. So this is a way of turning a numerical category or numerical feature like returns, which is on a scale, and turning it into a categorical feature of class, which is just a binary, positive or negative. Awesome. Okay, we could make more columns as well, but that is a great introduction. Coming up next, we are going to analyze the data set. I'm going to show you some handy properties and functions that we can use. So head on over to that next lecture.